Hello, my name is Keshwani. That's K-E-S-H-W-A-N-I, Keshwani. We are here because we want to prepare for GRE. We have been solving GRE math problems out of this book here, the official guide to the revised GRE, the second edition. If you do not own this book already, purchase one immediately. You're going to need it. The problem that we are about to solve is the one that you will find on page number 242. Please turn to it. Page number 242, and today is our lesson number 343. It's the exact same problem that appeared in the first edition of the revised GRE on the same page number. We have solved every single math problem from the first edition. If you're interested in watching the original solution, you will find the original solutions on day number 132 and 133. Let's see what we have here. There are two different functions that are given here. We'll tackle them one at a time. Let's first take a look at f of x. Well, actually, they don't actually give, in the book actually they do not give these functions names, and since I mentioned it, so let me tell you what I mean by this. First, let's plot what we're going to call f of x. We're going to call this function f of x, which is absolute value of x plus 2. And then we'll worry about the second graph, which we're going to call g of x, which is simply x plus 1 squared. For the time being, we're going to keep this in abeyance. We're going to keep it aside. Let's concentrate on this one. This is what is known as, this function that we're looking at is what is known as piecewise function. Now, if I can only figure out how to spell piecewise function. And I'm assuming that you have watched day number 341. If you have not watched day 341, stop this video immediately. Make sure you watch day 341 before you watch today's video, because what we're going to talk about today is going to build on what we talked about last time on day number 341 when we learned the concept of piecewise function. So here's what's going on. Let's not start with something complicated, let's just concentrate on this part. F of x equals absolute value of x, which is of course the value of y. So here's our x, here is our y, which we are told is absolute value of x, which is what we are calling the f of x. So we're going to plot it. When x is equal to 0, the absolute value of 0 obviously is 0. When x is positive 1, the absolute value of positive 1 is 1. 1, 2, 3, 1, 2, 3, 1, 2, 3. When x is 1, y is 1. What happens when x is negative 1? Well, absolute value of negative 1 is also 1. So absolute value of positive or negative 1 is 1. So when x is negative 1, I shouldn't have to explain all this thing in so much detail because we learned it already on day number 341. We know what the shape is going to be here. And similarly, the absolute value of positive 2 or negative 2 is going to be 2. Absolute value of positive 2 or negative 2 is going to be 2. When x is equal to positive 2 or negative 2, y is going to be 2. So when x is positive 2, x is going to be positive, y is going to be positive 2. When x is negative 2, y is going to be positive 2. When x is negative 3, y is going to be positive 3. When x is positive 3, y is going to be positive 3. And here's our function. This is what we learned on day number 341, which was on page number 241. This comes straight from 241. Now we ask ourselves, what happens if we take our original function, which we take our original function here, and we simply add 2 to it. So now y does not equal absolute value of x, it equals absolute value of x plus a 2. What do you suppose is going to happen? What's going to happen is that as a result of adding 2, the values of y is going to be 2 more than before for each given value of x. Let's write it down here. Now, when we have y is equal to f of x y is equal to absolute value of x. When we add 2 more to it, now the values of y are going to be 2 more for each given value of x. Obviously, this is very straightforward. So when x was 0, now it's going to be absolute value of 0 plus 2. When x is 1, it's going to be absolute value of 1 is 1 and then plus 2. When x is negative 1, absolute value of negative 1 is 1 plus 2. You get the idea. It's just 2 more. Everywhere the values of y are 2 more than before. It's the same exact graph, same exact figure. Nothing has changed except the values of y are 2 more than before for every single point. So let's do that here. So before, when x was 0, the y was 0. Now when x is 0, y is going to be 2. Before, when x was 1, y was 1. Now y is going to be 3. Before, when x was 2, y was 2. Now it's going to be 4. And so on and so forth. Same thing here. When x was negative 1, y was 1 before. Now x is negative 1, y is going to be 3. 2 more than before. Before, when x was negative 2, y was 2. Now it's going to be 4. That's all. So here's our new graph. Here's our new graph. What up? As we said before, it's the same exact graph, same exact shape, same everything. It's just that we have picked up our graph and we have shifted it 2 units up. Now, instead of positive 2, we had negative 7. If we had absolute value of x minus 7, we would have picked up our graph and we have shifted it down down the x-axis by 7 units. That's all it is. So we're done with that part. We're all done with that part. Let's move on to the second part. That's it. This is over. Now we're going to deal with the second part, which deals with the parabola. Parabola is going to get a little bit more complicated. So the part that we dealt with just now was the part that we learned on 341. Now we're going to move on to the stuff that we learned for parabola earlier. And now we go to the parabola. And this part that we are about to do is going to be simple. It's going to be simple recapitulation of day 337 and 338. Again, I do not have a luxury of repeating every single thing that we already learned, otherwise we'll never get anywhere. This is simple recapitulation of day 337 and 338. Now, if you're wondering what recapitulation means and what abeyance means, I erased the word. We just put down on blackboard abeyance. When did we learn about abeyance? Do you know? I know we learned it. What does it mean to keep something in abeyance? To keep something in abeyance simply means to keep something aside. We'll deal with it later. We learned the word abeyance on day number 9 in our vocabulary videos. And recapitulation, what does it mean? Well, you will find out for yourself. Day number 32. Just type in vocabulary words, day 32, and you will see the video and you will learn these words. It's always a good idea to work on your vocabulary at the same time while you're trying to work on your math skill, because both are necessary to get a decent score in the GRE. Obviously, I shouldn't have to tell you this thing. Obviously, as I said, it's bloody obvious. You know it. So here's our new function here, which is y is equal to x squared. What do we call the other one? We call the other one f of x. Let's call this thing g of x. Now this is going to cause problem because throughout my entire notes I'll refer to it as f of x, but we cannot refer to it as f of x because we call this function absolute value of x plus 2, we call that one f of x, and in a given problem, each single function has to be given a unique, distinct name. If we call that f of x, f is the name of the function. And again, if you're confused, it's a good indication that you have not been watching the video in sequence. If you're confused, if you're ever confused about any topic at all, just type in the topic. Here you're going to type in what is a function. What is a function, and then my name in the search area of the YouTube, and the video will pop up. If you want to learn a little bit about parabolas, just type in parabola and then Keshwani, and then it will pop right up, and so on and so forth. If you want to learn about slope, same exact idea. Any topic at all, just put it in with my name, prime numbers, Keshwani, and then the videos will pop right up. So this is our g of x here, and we are told that this is equal to y is equal to x squared. What is the shape of this thing? Do you know? Of course you know, because we learned it. We learned it on day number 337, 338. If you have not watched these videos, pause this, stop this video right now, go back and watch 337, 338 before you continue, because I'm not going to go into too much detail. It is simply a parabola. It is simply a parabola. Here, when x is equal to 0, y is equal to 0. When x is equal to positive or negative 1, y is 1. When x is equal to positive 2 or negative 2, the y is 2. So that's what it is. It's a parabola. It's a simple, ordinary parabola. When x is 0, y is 0. When x is 1, y is 1. When x is negative 1, y is 1. When x is 2, y is 2. And when x is negative 2, y is 2. And here we go. This is our standard parabola. I'm not going to bother with it. This is our standard parabola that looks like this. The question is, what happens when you pick it up and you begin to shift it left or right or up or down? Left or right or up or down. That's what we're going to talk about, but not from scratch. We're not learning it for the very first time. This is simply a recapitulation of day number 337 and 338. So let's learn. Let's take a look at it. There are four things that can happen. There are four things that can happen to a parabola. You can pick it up and we can shift it to the right. We can pick it up, we can shift it to the left. We can pick it up, we can move it up, and we can move it down. Four things. There we go, the first one. So the original function is y is equal to x squared, which is our g of x. Here's the first one. Y is equal to x squared plus a. What happens then? Which is our f of x, rather g of x. I'm going to make a mistake right now. Our g of x plus a. This a tells us that we are shifting it up by a unit. That's what it means. We're shifting it up by a unit. Moving up and down is not counterintuitive. Moving up and down is very simple. Whatever the value of the y was before, y before equaled x squared, now it's just 2 more than before, 3 more than before, 7 less than before, whatever the a happens to be. If it's x squared minus 7, then for each given value of x, y is 7 less than before. So it shifts down 7 units, the entire thing, just like we saw here, the piecewise function. We moved it up 2 units by adding 2 to x squared. All it does is that it moves the function up by 2 units. So the movement along the y-axis is not counterintuitive. When you add it, it goes up. When you subtract it, it goes down. Is the shift along the x-axis that are counterintuitive. We'll get to that in a second. Here's the second part. Y is equal to x squared minus b. So here we have our g of x minus b. This tells us that we are shifting it down by b units. So that takes care of the shift up and down along the vertical axis. Now let's talk about the shifts left and right along the horizontal axis. We need the room. We can do it here, I guess. y is equal to x minus c squared. This is same as g of x minus c. G of x minus c. This is how we write it. So wherever in other words, wherever the x appears in the function, we replace x with x minus c. Now when we say that wherever x appears in the function, we replace it with x minus c, that's actually a silly thing to say because there is only one place where x appears in the function. Y is equal to x squared. There is only one term. This function only has one term. We take our x and we replace it with x minus c. There you go. And this was g of x. This is g of x minus c. Question is, what does it do to the function? This is where the counterintuitive part comes in, and you will learn this thing when you go through these two videos. And what it does is, we don't have a luxury of time to go into that right now. What it does is that when you have a minus, it shifts to the right by c units. It shifts to the right by c units. It's counterintuitive. Even though we're subtracting c units from the x, but you shift it to the right. Let's do the fourth one. Fourth and the final one that we have to keep in mind is y is equal to x plus d squared. So here we have g of x plus d. And here, so this c here is what we're talking about. Here, we shift it to the left by d units. By d units. And as I keep repeating like a parrot, this is simple recapitulation. It's a recap what we've learned before on day 337 and 338. It is vital, it is crucial, it is imperative that you watch these two videos if you do not understand this concept, if you're not very familiar with the concept of parabola, because it does appear on the exam on a regular basis. That's it, we're done here. So now we're going to put everything that we learned together, we're going to put it together and solve the problem that is given to us here. That's all. So let's do it. We're done with everything. We're going to put together the original function, which was a piecewise function, and the parabola. Or can we do it? You need the room, obviously. I'm going to give you a second to do whatever it is that you have to do. So the first one was f of x equals absolute value of x plus 2, I believe it was. Absolute value of x plus 2. Yep. And that is simply absolute value of x would have been a v shape at the origin. Instead of origin, it's going to say the 2. 1, 2, that's all. There you go. So that's our f of x, which is absolute value of x plus 2. Now deal with g of x. G of x is x plus 1, I believe it was. What is the second one? It looks like plus 1 from the graph. I can tell it is plus 1, or is it plus 2? It is plus 1. X plus 1 squared. And that tells us that we're going to shift it to the right or left? To the left. Because it is positive, we go to the left. It is counterintuitive. We shift it to the left by 1 unit. That's it. It's a simple parabola. Parabola that sits like this. Instead of sitting here, it's going to sit right here. So there you go. There is your parabola. That's it, we're done. Let me redraw it with a different color so we can see it properly. There is our parabola, and that parabola is the g of x, which is x plus 1 squared. And the other one is our f of x, which is absolute value of x plus 2. And that is exactly what you see, that is exactly what we see in the graph on page number 242. But the point is, you have to be able to see all of these things immediately like that in the exam. Just by looking at the picture, you should be able to tell immediately what the equation of that thing is going to be. Because that's all they're going to ask you. They're going to either give you an equation and give you 5 graphs and ask you to identify the right graph that goes with the particular equation. So for this equation, absolute value of x plus 2 is just shifted up by 2. So if they give you these two equations and if they ask you to identify one of the 5 graphs, then the 5 graphs will have different combinations. You know, shifted left, shifted right, up and down, different ways, and obviously four of them are going to be the 4 most popular mistakes. And one of them is the right answer, which is this one. But you have to be able to recognize right away that this is plus 2, which means you're shifting it up, and this is plus 1, which means you're shifting it to the left. And that's all it is. Or they can give you a graph like this and simply ask you to identify the pair of equations that go with this graph, and in the 5 multiple choice answer choices you have 5 pair of equations, one for the piecewise function and one for the parabola, and our job is to recognize the right pair that goes with the given picture. That's all. I'll see you tomorrow, okay? Bye now.